Good morning everyone. ഞാൻ ഇവിടെ എടുക്കാൻ പോകുന്ന example 4 ആണ് of unit 4. So that is determine the function theta of r comma t satisfying dou square theta by dou r square plus 1 by r dou theta by dou r equal to 1 by k dou theta by dou t where t greater than 0 and 0 less than r less than a, and the conditions given are theta of r comma 0 equal to 0 and theta of a comma t equal to f of t. So for solution, let us take this equation as equation 1. That is, given that the heat equation in cylindrical coordinates dou square theta by dou r square plus 1 by r dou theta by dou r equal to 1 by k dou theta by dou t, where t greater than 0 and 0 less than r less than a, as equation 1. Say this equation as equation 1. Then in order to solve this equation 1, we multiply both sides by e power minus st. So we multiply both sides of this equation by e power minus st, and then integrate with respect to t from 0 to infinity. So we have first we have to multiply e power minus st on both sides, and then integrate with respect to t from 0 to infinity. Then making the use of the condition theta of r comma 0 equal to 0. That is, we have already given the condition theta of r comma 0 equal to 0 and theta of a comma t equal to f of t. So making the use of this condition, we see that d square theta delta by dr square plus 1 by r d theta delta by dr minus s by k theta delta equal to 0. Say this is equation 2. We get this equation 2, and for getting this equation 2, here are the steps. That is, equation 1 equal to, we have to multiply e power minus st on both sides and integrate with respect to t from 0 to infinity. So integrate 0 to infinity, dou square theta by dou r square e power minus st dt plus integration 0 to infinity, integral 0 to infinity 1 by r dou theta by dou r into e power minus st dt, which is equal to integral 0 to infinity 1 by k dou theta by dou t into e power minus st dt. So here let us take u equal to e power minus st, which implies du equal to minus s e power minus st dt. Then v equal to theta, which implies dv equal to dou theta by dou t into dt. Now, by using Leibniz theorem, we have dou square by dou r square integral 0 to infinity theta into e power minus st dt plus 1 by r into dou by dou t, dou by dou r integral 0 to infinity theta comma e power minus st dt equal to 1 by k into theta into that is theta into e power minus st 0 to infinity plus s into integral 0 to infinity theta into e power minus st into dt. Say this equation as equation number 3. That is, here we have taken dou square by dou r square and dou by dou r outside. Now we know that d by dx into integral a to b f of x dx equal to integral a to b d by dx of f of x dx plus d by dx of b of f of x plus d by dx a of f of x, a into f of x, for any integral in a comma b. Here a comma b are arbitrary constants. Therefore, d by dx into integral a comma b f of x dx equal to integral a to b d by dx of f of x dx. Now equation number 3. That is, this equation, which implies to dou square theta delta by dou r square plus 1 by r dou theta delta by dou r minus s by k theta delta equal to 0, which we have already given as equation 2. Here theta of r comma 0 equal to 0. That is, we have taken this condition to solve uh, this equation 2. So now theta tilde of r comma s is the Laplace transform of theta of r comma t. So we have taken theta tilde of r comma s is the Laplace transform of theta r comma t, theta of r comma t. So since theta of a comma t equal to f of t, this is already given in the question, theta of a comma t equal to f of t. It follows that theta tilde equal to f tilde of s on r comma on r equal to a, which is equation 4. Now, since theta tilde of r comma s equal to integral 0 to infinity theta into e power minus st into dt, which is equal to integral 0 to infinity theta of a comma t into e power minus st dt equal to integral 0 to infinity theta of t into e power minus st dt. So we have the condition theta of r comma 0 equal to 0. Now we have theta of theta tilde of r comma 0 is also equal to 0, where f tilde of s is the Laplace transform of the function f of t. If we make use of the physical condition that theta of r comma t and hence theta tilde of r comma s cannot be infinite along the axis r equal to 0 of the cylinder. So we see that solution of equation 2 appropriate to the boundary condition equation number 4 is theta tilde theta tilde of r comma s equal to f tilde of s I0 of kr by divided by I0 of ka. So now we have to multiply equation number 2 by r square. So we get r square theta tilde double dash plus r theta tilde dash minus s divided by k r square theta tilde equal to 0. Now let us take k square equal to s by k. So instead of s by k, we have to make this s by k equal to k square. So we have r square theta tilde double dash plus r into theta tilde dash minus k r whole square theta tilde equal to 0. So now we know that theta of r comma t equal to 1 by 2 by I integral c minus I infinity to c plus I infinity theta tilde of r comma s into e power st ds. So we have this from the portion of the use of integral transform. So using this, we have theta of r comma t equal to 1 by 2 by I integral c minus I infinity to in c plus I infinity f f tilde of s into I0 in kr by I0 ka into e power st ds. Now, if I0kr by divided by I0ka is the Laplace transform of g of t, that is, if g of t equal to 1 by 2 by I integral c minus I infinity to c plus I infinity I0kr by I0 of ka e power st ds. So if this is the Laplace transform of g of t, and if g of t is equal to this, we say this equation as equation 5. Then we make use of convolution properties here. So convolution f of t and g of t is defined and denoted by f star g equal to the integral 0 to t f of x g of t minus x dx, and f star g equal to integral 0 to t f of t minus x into g of x dx. Now by the theorem, if L of f of t equal to f of s and L of g of t equal to g of s, then L inverse of f of s g of s equal to integral 0 to t f of x into g of t minus x dx equal to integral 0 to t f of t minus x into g of x dx, which is equal to f star g. And L of f star g equal to f of s into g of s, that is L inverse of f of t into L inverse of g of t. And now that is L of integral 0 to t f of x into g of t minus x dx equal to L of integral 0 to t f of t minus x into g of x dx, which is equal to f of s into g of s. So this is the convolution property. So using this convolution property and the theorem, it follows that theta tilde of r comma s equal to f tilde of s I0 kr divided by I0 of k. That is L of theta equal to f tilde of s I0 of kr divided by I0 of ka. Then theta equal to, we have to make this L here. So when this L comes to here, we have L inverse. So theta equal to L inverse of f tilde of s into I0 kr divided by I0 of ka, which is equal to f of t into g of t. That is theta equal to integral 0 to t f of t dash into g of t minus t dash into t dash. Thank you.